Is this better? Okay, perfect. Thanks. Sorry for that, guys. Um, Sorry for the technical difficulties. So let's get going. Looking forward to having Ethan update the group on the genomic sequencing. So unfortunately, Japan looks like they're continuing their upward trend. As it's halfway through April and the Olympics coming up in a few months, we'll continue to keep an eye out on that. And as we have increase in tourism for Hawaii, even with our safe travels testing protocols, and especially as we, start to see more concrete details on a possible vaccine passport. We'll see how that impacts our state as as our tourism continues to rebound. On a national overview, we're still holding relatively steady, no major surge. However, of concern is that we're still averaging around 60,000 new cases a day, and unfortunately, that's still at a level where it's one where we have to continue to monitor, because any true setback could trigger another surge, even as we are doing pretty well. Over 30% of the adult population in the United States is fully vaccinated. We still need to monitor our COVID case conditions across the country. Arizona and California, however, are remaining relatively flat, which is awesome. And Nevada and Texas a little higher, slight trend upwards, but nothing too much of concern as of now. So we'll still continue to monitor those four states, especially as our tourism is ramping back up. Looking at our Hawaii specific overview, Maui is trending back down, from their Easter weekend and the cluster that they were experiencing a couple weeks prior. The other counties are relatively flat and stable with regards to their cases per 100,000, as well as our percent positivity. I think moving forward, this is probably where we're going to see a lot of our counties continuing to stay, at least until we get more of our population vaccinated. Our state continues to do a great job getting shots in arms. And I'll speak about the Johnson & Johnson issues this week, but thankfully, from the press releases from our Department of Health, we weren't expecting a big shipment of Janssen vaccines, so there really wasn't much of a hit to the state in terms of possible shots in arms, but we continue to do very well in terms of vaccinating our older populations. For our testing turnaround time, no major changes or concerns this week. And then for our Hawaii specific 14-day forecast, nothing too major in terms of what we're projecting, looking at all of the overall metrics and travel, hospitalizations, nothing that we expect to really impact and burden our hospital systems. So looking good on this front. So a few science highlights. I believe everybody is aware of the first one. And then there is a really good article I recommend reading and potentially sharing with your friends and your colleagues in terms of, promoting confidence amongst the vaccines, amongst some of the hesitancy and the what is perceived to be bad news, but it's of the Johnson & Johnson vaccine. So I recommend reading this Atlantic article. And then finally, as travel continues to tick back up, and I believe United was the most recent airline to remove metal seats. There was a modeling paper that was published in MMWR that shows continues to show the benefit of reducing the middle seat. So earlier this week, CDC recommended pausing the distribution of the Janssen COVID vaccine due to potential severe blood clots. However, with updated data this morning and this afternoon, the epidemiology is showing that it's quite rare, less than 1 in a million vaccinated, and it's actually more likely amongst people who naturally acquire or get COVID than those who get vaccinated. So we're looking for, I believe, another meeting by ACIP, I believe, next week, and that will provide further recommendations for ways forward for the Janssen vaccine. So once again, several other countries have paused it. What I will say is, in response to some of the naysayers or the vaccine hesitants or the those who are not for vaccinations, this is proof that our system works. We tend to be very safe and sorry when it comes to these practices, and this proves that we're the approach for vaccines and vaccine relevance is very much data driven. Even though common sense and looking at the overall epidemiology shows that amongst the general population there's no increased risk. It's just that we want to do our due diligence with regards to these deep vein thrombosis. So just something to discuss when you have friends or family or people you talk to who are using this situation to show that vaccines aren't safe. You need to speak to the epidemiology and the overall mechanisms with which this whole process occurs. And another positive note is that one of the major points of concern with a lot of the population with the Pfizer and Moderna vaccines was that mRNA vaccines are new and we don't know anything about them. What should have been messaged consistently was the technology is not new. We've been studying this for over 10 years. It's just the first time we've actually rolled it out in a vaccine. But what this this Atlantic article shows, sorry, not the CIREP, but the Atlantic article shows is that truly we are lucky to have the mRNA vaccines be so prevalent within the United States. It's still very safe. The Janssen vaccine, AstraZeneca vaccine work slightly differently than the mRNA vaccines. We should count our blessings that a majority of the vaccines that have been acquired for our country and for our state are of the mRNA variety. So this is just a good summary piece, and the science is not hard to digest. So I recommend reading this and sharing this with all your friends and family. Finally, didn't want to spend too much time on this, but this is once again important, especially for Hawaii, as everybody understands. Tourism and travel play such a big role in the livelihood of our state. So in this MMWR paper report, they did some modeling, and they showed that physical distancing of airplane passengers, such as through policies of middle seat vacancy, can continue to reduce possible transmission. I do remember reading an article or an op-ed that was circulated in Civil Beat. They acquired it from a national group, and they actually advocated against the they said it's actually no significant, it doesn't have any added benefit, and they looked at some numbers of the of cases of COVID cases in the destinations where arrivals did not have any middle seat holdings, and they came to the conclusion that there is no benefit. However, if you do come across and you do look at Civil Beat, that Civil Beat article, they don't account for a lot of typical epi variables. It was very much of a correlation, does not equal causation type of comparison. And unfortunately, they were not epidemiologists or hard scientists. So promoting from a slightly different perspective, and I think that was pause for concern when I read that. So if you are interested, I recommend looking at that and comparing that to this particular paper. Not seeing any. Thanks, Janet, for sharing some of those sources with regards to the Janssen vaccine with the group. I'm not seeing any questions from our participants with regards to the science or the data highlights. With that, I'm going to stop sharing my screen and hand it off to Ethan, and I'm looking forward to this awesome update. Take it away, Ethan.
Awesome. Thank you so much. Hello. Oh yeah, this is a panel. That's right. I hope everyone can see me and hear me. Please let me know if
We
you
read
cannot.
you loud and clear.
Awesome. Thank you. All right. So let me go ahead and share my screen. And all right. So can everybody see? Oh, there we go. Perfect. Can everyone see the screen? Awesome. So, hello, everybody again. My name is Ethan Hill. I am a graduate student in the lab of Dr. Marguerite Butler. And today I will be updating everybody on the progress that our lab has made in regards to using genomes or genetics to look at the spread of the SARS-CoV-2 in Hawaii. So let's get started with a little background first. So SARS-CoV-2 first appeared in 2019. It was a novel virus that was originally linked to a cluster of pneumonia cases in Wuhan, China. And in the early days of the pandemic, a lot of effort went into understanding its origins. And relatively quickly, the complete genome of SARS-CoV-2 was sequenced and published by a group in China. And the publication and sequencing of this genome allowed for them to conduct a genetic analysis that identified it, one, as a beta coronavirus, and two, strong evidence for zoonotic transmission between bats and humans. Now, through the pandemic, the primary way that we have been understanding the spread of the virus was through contact tracing, or is through contact tracing. However, contact tracing does pose some limitations, especially in regard to COVID-19. And these limitations are primarily because of asymptomatic transmission, pre-symptomatic transmission, and long infection periods. And as a result of these difficulties, many cases may appear to be invisible to traditional contact tracing methods. Now, what can we do, or what have we been trying to do, to supplement the contact tracing efforts? Well, we've been trying to use the genetic information within the SARS-CoV-2 genome to trace transmission chains. So the SARS-CoV-2 genome contains a lot of information and has been well studied ever since the beginning of the pandemic. All the relevant functional regions for viral replication and creation have been identified, but more importantly, the rate of mutation of the genome has been identified. The genome mutates at a rate of about 2 per month, and given a 14-day infection cycle, you're looking at about 1 mutation per every host transmission. And what these mutations do is essentially act as a fingerprint, marking each sample as unique, which means as we collect more and more genetic sequence of SARS-CoV-2, each of them will be unique to the individual that it has infected. And the only reason that this is possible is through the recent advancements in sequencing technology and computing power, which allows us to generate a large amount of genetic data and process that genetic data within a matter of days. It's honestly very, very fast, which allows us to take this genetic information and use it to study and trace the movement of SARS-CoV-2 in real time. This method has been used in the past to study things like the yellow fever, but a lot of these previous studies have been backwards facing. And because of the advancements in technology, we're able to do this in real time now. And this was only made possible, in addition to the sequencing technology, this was made possible through worldwide collaboration. There's a huge effort going on that is generating large amounts of genetic data, and as well as sharing protocols and data processing pipelines in a standardized format that makes it accessible to pretty much everyone who wants to study the SARS-CoV-2 genome. And all of this information is uploaded to the GSAID database, which was originally created to hold influenza data, but now has been updated to hold SARS-CoV-2 data. And GSAID does their own series of analyses on a weekly basis as well. They mainly focus on strain detection, clade evolution, as well as the distribution of the different clades of the virus. However, the one limitation about GSAID with their weekly analyses is they do it at a very coarse scale. They look at things from a global perspective. So what do we do if we want to take a look at things at a smaller scale, say in Hawaii? Well, we can take the data that has been uploaded to GSAID and process it in our own smaller way to do more fine-grained regional analyses. And I want to take a moment to mention that all of this analyses that I'm about to present is only made possible by the great efforts of the DOH and their vigilant sequencing recently in March 2021, and I believe into April as well. Currently from Hawaii, they have published 1,064 genomes into GSAID. And in addition to the genomes that they published, they also have the sampling date as well as the county associated where the sample was collected, which is really, really cool stuff because that's all we need to conduct an analysis that we're going to do. So using the SARS-CoV-2 data, we can ask a couple big questions. The first question we can ask is how does SARS-CoV-2, or the big question we can ask is how does SARS-CoV-2 spread to and within Hawaii? We can also look at how many introductions into Hawaii can we identify from our genetic data set, as well as how many introductions result in community transmission. Finally, we can also look at the pattern of transmission within the state of Hawaii. So I want to go over a sampling strategy real quick. So we took all of the genomes published by the DOH in GSAID, which is 1,064, across 4 counties to include all of the genetic information of SARS-CoV-2 we have for Hawaii. And what we wanted to do is, as we know, Hawaii is not a closed system, was include genomes from outside of Hawaii as well. However, we didn't want to randomly sample in the case that we might miss some genomes that are linked to Hawaii. So what we did instead is we took a look at the huge family tree that GSAID produces on a weekly basis. And we looked for all of the locations of the Hawaii genomes in this larger tree. Once we identified where those genomes are, we then took all of the closely related genomes that were not from Hawaii that are related to those, and then combined those into our data set. And what that looks like is 49 genomes from the United States. And if you take a look, it's actually pretty interesting how it's distributed. Personally, I was expecting a lot of them to be clustered on the West Coast, but what we can see is that the genomes are from the West Coast, from the South, as well as from the Northeast, which I thought was a pretty interesting distribution, but it makes sense since Hawaii is such a popular travel destination. And in addition to the domestic genomes, we also looked at the international genomes that were related to the Hawaii genomes as well. And what we found were 19 international genomes that were related to the Hawaii data set, spread across 10 countries. Canada, to no one's surprise, and a fair amount from Europe. So Wales, England, Sweden, Switzerland, and France were a major source of Hawaii genomes, as well as some spattering in Japan and China, a couple from India, and a couple from Australia. And also, I just want to give a heads up that we are also doing our additional SARS-CoV-2 sequencing in our lab, which is currently underway as well. So we're contributing to the big data set. So we took all the genomes that we collected, which totals to about 1,136. And with sampling dates between January 2020 all the way to March 2021, and we created this huge family tree for all of the genomes from Hawaii. So this is what it looks like. It is a huge tree. I'll just leave it up here to let everyone everyone take a look at it. But more importantly, with this huge tree, we can begin to identify sources of introduction. So how many introductions are there? Well, basically, I went through the tree and looked at all of the locations where we find a genome that is not part of the Hawaii data set leading into a huge cluster of genomes that are a part of the Hawaii data set. And we found that there were 28 of them. And I do want to preface this by, I do want to make note that this is a very conservative estimate, and this was the estimate we were able to make given our data set. And another thing I want to talk about is that not all of the introductions persist. A fair amount of them will see an introduction followed by like a single case in Hawaii, then it's cut off. So there's no further transmission after this. So of the 28 introductions, how many of them actually resulted in community transmission? Well, about 10. And you can see that they're marked in red on the tree. And you can see that each one of these 10, or each one of these red circles results in a huge cluster of cases. And for a little bit of background, I called anything greater than 3 descendants indicating some sort of community transmission. The reason I picked 3 was because the average household size in Hawaii is about 2.9. So I wanted to use like 3 or more to get an idea of any sort of out of household transmission, which we could then say is potentially community transmission. And to give you a brief look at what a community transmission case looks like in the tree, here's a quick zoom in. So we can see an introduction here at the top from Washington, resulting in a huge cluster of cases on Oahu. So now that we have the data and we have the tree, how exactly do we model the spread of SARS-CoV-2 in Hawaii? Well, we can do that with the use of a DEC model, or a dispersal extinction cladogenesis model from evolutionary biology. And I'll make it really simple. So basically what we start with are the genomes of SARS-CoV-2. And then we create a family tree of how the genomes are related to each other. Now, in addition to the genomes, we can then include geographic data linked to each genome. And in our little mock example, I said 2 of them were from Maui and 1 of them was from Oahu. What we can then do is go backwards and mark the point where the 2 genomes, say from Maui, share a common ancestor. And we can infer that this common ancestor was probably from Maui. And if we take another step back in the tree, we can see that they share a common ancestor with a genome from Oahu. And we can mark that as coming from Oahu. And we can then use these regions of origin to infer geographic spread between regions. In this case, we can infer that there was movement between Oahu to Maui. And also, for the scientists out there, we did do a model comparison. So we compared 2 models, one looking at adjacent spread and another model looking at long distance spread with very, very rapid changes in geographic region. And the long distance dispersal model fit a lot better, which is not really surprising, seeing that Hawaii is not really connected to anything. So now for the fun part, or well, the interesting part. What do the pattern of spreads in these models actually look like? So the first pattern of spread we'll go over is a pattern of spread coming out of Oahu starting in August of 2020. So quick context for everybody. The part of the tree I will be talking about is on the left-hand side. The map showing the movement is going to be on the right-hand side. And also through this analysis, we are able to estimate an RT through time as well, which I have at the bottom. All of the relevant points will be marked in red as I step through the progression, so keep an eye out for that. So let's get started. So in this first chain of transmission, what we can see is a movement, or the origin of this chain of transmission was from Oahu in about mid-August. The first jump we can see is between Oahu and the Big Island that appears to start in early September. And then we can see in mid-September, early to mid-September, we can see another jump back from the Big Island to Oahu, marked in red. And you can see that this jump from the Big Island to Oahu actually resulted in a cluster of cases here, which is coincident with a small bump in RT that was estimated from our analyses as well. We can then see a third jump from the Big Island back to Oahu again, this time occurring in like late September, possibly early October, this time only resulting in one case. We can use this to look at other patterns of spread too. So I'll look at another chain of transmission, this time again coming out of Oahu in around September. So what we can see here is two separate introductions to the Big Island, two separate independent introductions to the Big Island from Oahu, starting in about October. We can also see in about early to mid-October a single introduction from Oahu to Maui. Now, what happened after that single introduction? Well, from the tree, we can see we have a whole bunch of extremely related genomes clustering together, what almost looks like a super spreader event. And this is evidence for a large amount of community transmission happening extremely rapidly. And we can see that the corresponding estimated RT that happened during this time also experienced a bump. And this is a whole cluster of cases that came up from a single introduction within the state. So the last chain of transmission I want to look at is a very interesting one that describes how it's coming into Hawaii. This time it's starting in September. So we can see that there was an introduction into Oahu starting in September that originated from Wisconsin. And then we can see that it hung around a little bit, but then went out of the state into Montana. At time point 3, we can then see a whole bunch of inter-island movement. So starting in Oahu, we can see that it moved from the Big Island, moved to the Big Island. We can see that it moved to Kauai, and we can see that it moved to Maui, all within a very, very short time. And I want to draw everyone's attention to the date of this spread right here. So this inter-island movement, or this large amount of inter-island movement, is coincident with the holiday season, where we experienced a large number of cases, if everyone remembers. And through our analysis, we can also see that there is a spike in RT that occurred in December, moving into the early part of 2021. And we actually were able to pick up on this movement in our analysis, which is really cool. And then we can see yet another introduction from Oahu to Maui in late January or early February. And another thing we wanted to address is what do the introductions look like in relation to the RT through time? So I have all of the 28 introductions marked in red here. And what we can see is that the bulk of the introductions happened, or well, I think there's 13 introductions happened in the early days of the pandemic before the state shut down, so between March and April. What you'll notice is that in June to about September, there were very, very few introductions. I believe there were only 2 that I was able to identify. And then we continued, and then we started seeing more introductions starting in October, moving through the end of last year into the beginning of this year, which is coincident with the opening of the state and the start of the Safe Travels program. And in addition to just when these introductions occurred, I've also marked the introductions that resulted in very large amounts of community transmission. So we can see that the majority of community transmission introductions occurred in the beginning of the pandemic as well, so between March and April, with only 1 introduction resulting in community transmission occurring in late May, early June. And finally, there were 3 larger clusters of community transmission that was linked to introductions that occurred during the holiday season, which again happened during that spike in cases that we saw through the holidays. So some of the big takeaways from this analysis is that not all introductions result in community spread. Only about 35% of them do. And the majority of cases in the island are a result of community transmission. And through an analysis like this, it's very easy to identify the exact change of transmission in a geographical context. And we can see, you know, where a particular transmission chain started, where it ended, how it moved. And although I didn't talk about it too much, my colleague Claire is currently working on identifying the strains and variants that are present in Hawaii. And through an analysis like this, variant and strain detection is very easy to do. And finally, some of the future things that we want to do with an analysis like this are to infer hidden transmissions throughout the tree. Basically estimating how many people did it pass through to get to the person that it was sampled in. And we can do this through the use of the tree as well as through the use of the mutations in the genome to get an idea. Because remember, we know how quickly the genome mutates. We can hopefully estimate how many people it passed through to get to where it was sampled. We're still kind of playing with this, but this seems like a really cool thing we can try to integrate in order to get estimates for total population size in Hawaii. So on that note, thank you for listening. I'll take any questions. I also want to give a super huge shout out to well, Dr. Butler, who's been amazing through all of this, as well as my lab mate, Claire Fraser. I want to thank you guys at HiPAM for allowing me to present, and UH Manoa GSO for allowing us some seed funding to actually get our own sequencing efforts off the ground. And finally, I want to give a special shout out to Iolani School, who actually lent us their equipment to sequence our first round of SARS-CoV-2 genomes, which was huge. And although they're not here today, I want everyone to know that they were great, and they were a huge help through starting this process. Thank you.
Awesome. Great update as usual, Ethan. And hopefully whenever Claire is ready, we can have her update the group as well. But any questions for Ethan from our group? I know Lee had a comment in the chat, Ethan, if you want to take a look at that.
Perfect. Let's see here. Oh, yes. Shinji picked up the P2 sequence from Brazil. So I think I need to go back. There is a chance we might have missed some in the larger tree. Just for some context, that large tree that is generated by GSAID contains close to 1 million sequences. So there is a chance that we missed it. But I can definitely look at it specifically. Or look for that specifically and see if it's related to anything in Hawaii, because that is definitely a very interesting connection that should be made there. Let's see, another question. Oh, was David Masanaga your Iolani connection? Oh, no, actually, it was Dr. Yvonne Chan from the science department and Eric Tong. We're both campers. Oh, that's pretty cool. Oh, it's a really small world. Yeah, I think he teaches math, right, at Iolani? Something like that. see, another question. Oh, from Jim Raymond. Is it possible to use your data to show hypothetical effects of stopping individual introduction points? Let's see. So we wouldn't be able to, I guess, model anything like that. But what we can see is that, I guess it's a hard question to answer. So I do apologize if I kind of stumble through it. But we don't have information about, I guess, so we don't have information about the travel history. So we don't know, I guess, if a case was successfully quarantined and stomped out that way. But yeah, also, yeah, Lee has a very good point that deleting introductions would just erase the entire tree at its point of origin. So all subsequent transition change would just be taken away.
Yeah, Ethan, one point that Marguerite had was, the sampling that you guys are doing is, while it's amazing and adds a lot to the insight, it's still only 5 to 10%. So it's hard to generalize what we're finding to the overall population. Understanding there's always, exceptions to whatever rule that we're finding.
Yes,
Yeah,
that is definitely true.
Yeah, I just want to add in that that's why increased surveillance genomic sampling would be really helpful. So that's why Ethan caveated with the 28 as being very conservative, because this is only a sample of about 5 to 10% of the genomes. So we don't know how big those error bars are around the number of introductions. More would be better, and then, but sure, you could delete some, or you could look at the effect of reducing, by 10%, by 30%, what would happen? You're going to get wild swings though, because you can see that some introductions are explosive, right? So, but definitely stopping introductions would help.
Definitely. Let's see. Oh, a question from Lee. What about the Hawaii P2 sample? Where did it connect into worldwide sequences? That's a very good question. And I will have to refer to Claire for that. I don't believe she's here today, but she is the one working on the variants. So I will definitely ask her to see if she's analyzed that, and I'll get back to you on that.
Any other questions for Ethan at this time? Oh, question from Nicole. Yes, Nicole. Will the slide deck that that Ethan presented along with the rest of the HiPAM webinar will be uploaded onto our website later this evening or first thing tomorrow morning, and snippets of the recordings will be available. So you'll if you just visit hipam.org, you'll be able to view the material thing. Ethan, another comment from Lee.
See, you could calculate the mean time since introduction of the population and see it changes time. Oh, that would be really interesting. Yeah, let me write that down. Yeah, and I think that that's a very good point to bring up, especially if I refer to this, that's the wrong way. If I refer to this last chain of transmission here, we can see that it was introduced, so this particular transmission chain was introduced back in September, but we didn't really see it blow up until December. And an interesting thing to point out, especially in a tree like this, with you see some of the longer branches, implies there is more genetic distance between two samples. And there were definitely mutations that occurred, and I guess hidden host transmissions between. And that's the kind of the next step we wanted to take, because we can see if we can infer how many, I guess, hidden steps there were between the sampling of two individuals. If we decrease the mean time, the cases are being driven by recent introductions. That is true.
Can you state the question?
Oh, sorry. It was more of a comment than anything. So Lee said that you could calculate the mean time since introduction to the population and see how it changes. The next comment would be a decrease in mean time means that the cases are being driven by more recent introductions.
Yeah, and also we have to understand the sampling strategy of the DOH better. That would be helpful. So we are currently trying to get funding, grants, and whatever funding we can find to just increase the amount of surveillance sampling so that we can have more even sampling, representative sampling, as opposed to sampling related to contact tracing or cluster detection.
Let's see. Oh, here, a question from Nicole Ferguson. Are future sequencing efforts going to focus more on breakthrough infections of vaccinated patients? We're seeing more of that at our testing sites on Maui. So that's a good question, and I believe a question that has to be answered by the Department of Health. Currently, to our understanding, they are focusing their sequencing efforts on travel-related cases, so any case that has some sort of travel history linked to it, as well as cases that are linked to large outbreaks. So the data is a little biased in that way, but I feel like that's definitely something that sequencing efforts should be directed towards as well.
That's really scary. Nicole, if you folks would like collaborators, we would love to collaborate. So the DOH is tracking that information. We don't have access to, the patient information, like who's been vaccinated and so forth. We're just like sequencing and analyzing, but we would love to find partners where we can help. And if you have the information, we could join forces to try to figure out some of these difficult problems. Because, yeah, clearly breakthrough infections are of great concern.
Definitely. A comment from Jim Raymond. Yes, you might find more funding interest at a national level if you aren't currently reaching out to NIH. Yeah, so we are looking for funding. We did submit an NIH grant back in October. We submitted it when we were a little more naive about what we were doing. But yes, we definitely are looking for funding, maybe at that level, now that we have our analyses more fleshed out.
Yeah, the problem with NIH funding, which we do go for, is that it's like typically a 1-year lead time from application to funding if you get funded. So it's really difficult to try to fight the pandemic with that route of funding. But anyway, we're doing what we can. And I guess if others have access to CDC funding or other more rapidly dispersible funding, that would be very helpful.
All I can say for the group and for the rest of the enterprises, we're very grateful for the work that Ethan, you're doing, and Marguerite, as well as the rest of your lab, and Claire, because this provides a lot of nuanced information that where we're not capturing from regular contact tracing. So thank you for that. And I know it helps our modelers and all of our core HiPAM members better understand transmission, specifically within our state. And hopefully that'll inform policy. That's the goal, and educate. So we'll continue to look forward to updates from your lab as we continue to move forward in this response. I don't see any further questions. So Ethan, thank you again so much for your time and for your willingness to share. And hopefully we'll have you on sooner than later when you have additional updates. With that, yep. Yes. We always want more from your lab and from your colleague Claire and Marguerite's lab. So whenever you guys have more, just let us know. We'll love to have you on. But yeah, we'll see everybody next week, Thursday. Hopefully we'll have some positive news with the Janssen vaccine, and continue to look for updates. I can't believe it's April, and I think this is around the time that Hawaii shut down, or a little after that last year. So we've made our anniversary, and hopefully we'll continue to only move forward and upwards from here. But have a great weekend, everybody, and we'll see you next week. Thank you.